So we're going to learn how to solve quadratic equations using the zero factor property. Now the zero factor property involves factoring, and you're going to see this in a little while. But in order to use the zero factor property, though, the quadratic equation has to be factorable. Not all quadratic equations are factorable. So later on in the course, you're going to learn how to solve those equations using the quadratic formula. But for right now, though, our focus is on solving quadratic equations that are factorable using the zero factor property. Now, first of all, a quadratic equation has this form. So it's ax squared plus bx plus c equal 0. And this is in standard form. And if it's factorable, so if we have a quadratic equation that's factorable, we're going to go ahead and solve it using the zero factor property. Now, before we talk about the zero factor property, let's kind of remind ourselves about something. So this is kind of a review, I guess. So if you're told that you have two numbers whose product is 0, okay? Two numbers whose product is 0, and let's say one of them is 7. What must the other one be? What must this be in order for this product to be 0? Well, definitely this number has to be 0, right? That's the only way you can get a product of 0. And so that's basically what the zero factor property says. So it basically says, I'm going to go ahead and write this down. So this is zero factor property. Now sometimes the word property could be replaced with principle. So the zero factor principle, okay? So sometimes you'll see property, sometimes you'll see the word principle. So basically it says this. If you have, and in this case we're going to look at two factors, but it could be more than two factors. It could be 3 factors, 4 factors, whatever it may be. But if you have two factors, A and B, okay, A and B, and you're told that their product is 0, then the only way that this product can be 0 is if A is 0, the factor A is 0, or the factor B is 0. Okay? And that's a zero factor property. So if you have two or more factors whose product is 0, then one of those factors has to be 0. Okay? And so, for example, let's look at this equation. So we're going to solve this equation. So number one, let's suppose we have x plus 5 times x minus 7 is equal to 0. Now, first of all, I want you to understand, do you realize that this is a quadratic equation? It's already in factored form, but it's quadratic, which is you FOIL this, what's x times x? Well, that's x squared, right? So if you notice, if you FOIL this out, you would get x squared. The outer is negative 7x, the inner is 5x, you get minus 2x, and then the last is minus 35. So you see this is a quadratic equation, and it's in standard form. So this is already factored, so it's been factored for you. But I want you to notice something. How many factors do you see? You see two factors. You see this one, x plus 5, and you see this one, x minus 7. So if you're told that these two factors have a product that's 0, then according to the zero factor principle, one of them has to be 0. And so if you want to solve this equation, if you want to solve this quadratic equation using factoring, which we're going to apply the zero factor principle or the zero factor property to it, then the next step is to take each of those factors and set it equal to 0, because that's what the zero factor property says. So we get this. So notice I went from a quadratic equation to two linear equations. You see that? And so I'm just going to solve these linear equations. So if I solve for x, I get x to be negative 5. And if I solve for x here, I get x to be 7. So those are your solutions. So this quadratic equation has two solutions. And notice it has two solutions basically because if you look at the factors, these factors involve variable. So these are variable expressions and they're different. They're different variable expressions. Those factors are different. Then we end up with two different solutions. And so those are your solutions. Okay, so and you can check, if you check, let's check -5. If I substitute -5, so let me go ahead and write this right here. So let's check x equal -5. So if I substitute x equal -5, then this side right here better equal 0. And it does, because look, I get -5 plus 5. So remember letting x be -5 times -5 minus 7, and I get 0. So I want to see that 0. Well, this is 0, right? And this right here, what's that, -12? And so 0 times -12 equal to 0? Yes. All right. And if I do the same thing with 7, if I check x equals 7, I'll go back to the original, and wherever we see the variable x, I substitute 7. I get 7 plus 5 times 7 minus 7, and I will see that's equal to 0. And it is, because 7 plus 5 is 12, and then 12 times 0 is 0. Okay? All right, so that's basically what's going to happen. So, and it's most students don't have any issues with using the zero factor property. They find it fairly easy to deal with. But remember this, though. So if it says show work, then this is the work you got to show. So each step, you see how I said each factor equal to 0? You must write those as equations. That's important. You must say this equals 0, this equals 0. That is important. If you want your full points, you must do that. And then you can skip some steps here, since that's pretty easy to do. So most of you know that if x plus 5 equals 0, then x has to equal -5. Okay? But you must show each of those factors being set equal to 0. Okay? All right, number 2. So number 2, let's suppose we have 8x times x plus 5 is equal to 0. Okay? Now, technically, you see this is in factored form. Y'all see that? And do y'all see also that this is a quadratic equation? Because if I distribute that 8x right here, you get 8x times x is 8x squared, and then 8x times 5 is 40x, and that's equal to 0. See, that's quadratic. So you have a quadratic equation. Now, it has 2 terms, whereas this one had 3 terms, but it's still quadratic. That's a quadratic equation. But I want you to notice that it's already factored for you. So if it's factored, once this quadratic equation is factored, then you can use a zero factor property. Now, keep in mind though, you see how if you look at your factors, there are really 3 factors. 8 is a factor. Remember, factors are when you factor a polynomial, you write as a product of factors. So 8's a factor, x is a factor, and x plus 5 is a factor. So there are really 3 factors. But what we normally do, what students normally do is when they have a monomial, see, remember we kept talking about monomials in previous lessons? When we have a monomial factor, we just set that whole thing equal to 0. So we'll say 8x equals 0, and then I'll set this equal to 0, so x plus 5 equals 0. Okay? And so if I get x by itself here, I have to divide both sides by 8. I'll agree. So divide both sides by 8. And so 8 divided by 8 is 1. 1 times x is x. And 0 divided by 8 is 0. So one of my solutions is 0. And it kind of makes sense because look, if I were to, watch what happens. So if I check this, I get 8 times 0 is 0, right? Okay, and what's 0 plus 5? Well, 5. Well, what's 0 times 5? Well, 0 times 5 is 0. All right, let's look at the next one. So if x plus 5 equals 0, then what does x equal? Well, it must equal -5. So there's your other solution. So those are your 2 solutions. And if you check it, watch what happens when you check it. So notice that when I set each of those equal to 0, then when I substitute in, then that solution here will make that factor 0, because that's the only way we can get a factor of 0. So for example, see that -5? Which of those factors, when I substitute -5, which of those factors will end up being 0? Will be this one, because that's how I got 0, right? I got 0 by setting that one equal to 0. And so I get -5, and look, what's -5 plus 5? Well, 0. And 8 times -5 is -40, but it doesn't matter because -40 times 0 is 0. Okay? So those are your 2 solutions. Now, let me just remind you how you're going to write this, though. Depending on on my math lab, or if it's paper pencil. So on paper pencil, you'll just say something like this. You could say something like x equals 0, comma, -5, or you can say x equals 0, comma, x equals -5. Doesn't matter. Now on my math lab, it's going to ask you to separate it using commas. So what's going to happen is they're going to have a brace. They're going to have a brace in my math lab, and then inside that brace, which means your solution set. So inside that brace, you just list the solution. So you'll say 0, comma, -5. Okay. Now, if you put in here, if you put x equals 0 and x equals -5, is going to mark it as wrong, because what they want here is just the numerical solution. So remember, my math lab, make sure you only put the numerical solution. If you put x equal and x equal in here, it's going to give you an error because they're looking for a number, not a variable inside of it. Okay. All right, so that's number 2. So zero factor property. Now notice what's happening. Whenever we use a zero factor property, this was in factored form. So what's going to happen is, in a little while, you're going to go from a quadratic equation. You have to factor it. Once you factor it, you use the zero factor property, and you solve the equation, and you found your solutions. Okay. All right. So again, notice so far when we solved this quadratic equation, we factored. We went from a quadratic equation to 2 linear equations. We went from a quadratic equation, see it, to 2 linear equations. Okay. All right. Number 3. So let's suppose in number 3 I had this in number 3. Okay. So number 3. Let's suppose we have 6 times 2x minus 1 times x plus 4 equal 0. All right. Now, again, I have this quadratic equation. This quadratic equation, and I just want to remind you, you can tell it's going to be a quadratic equation, because if I cover this monomial factor here, which is a number, if I cover it up and I foil this, I get 2x times x is 2x squared. The outer is 8x, the inner is the -1x, so I get positive 7x, and then -1 times 4 is a -4, and that's equal to 0. But remember, you multiply it by 6. So if I multiply this by 6 and I distribute, notice I'm going to get 12x squared plus 42x minus 24 equals 0. So this right here is this quadratic equation. And so what's going to happen in our lesson is that at some point, you will be given this, and you have to factor to this. Okay? All right, so now once it's in factored form, that's where we use the zero factor property, or the zero factor principle. Okay? So notice, though, how many factors do you see here? You see 3 factors. You see a factor of 6, you see a factor of 2x minus 1, and you see a factor of x plus 4. Now, remember, whenever we set each factor equal to 0, notice that those factors that gave us solutions were factors that had variables in them. Okay, so variables in them, 8x, x plus 5. Over here, though, I want you to notice something. You see the 6? The 6 isn't a variable expression. It's just a whole number, right? It's just a real number. So what you do here, what you do in using zero factor property, is just take the factors that have variables in them, those 2 factors, and those are the one you set equal to 0, because that's the only way you can get a product of 0. This is always going to be a 6. That's always going to be a 6, so it's never going to be 0. This is going to be 0. This will be 0 when 2x minus 1 equals 0. And so if I solve for x, I get 2x equal 1. And then if I divide both sides by 2, I get x to be 1/2. So there's one of my solutions right there. So this solution will make this side equal to 0, because if I take this, substitute back into here, that's going to be 0. And so 0 times 6 times whatever this will be what? 4.5 will be 0. Okay? So you just set, when using the zero factor principle, you just set the factors that involve variables to 0, because that's the only way you can get a product to 0. This is never going to be 0. That is always going to be a 6. And so if I do the same thing here, I get x plus 4 equals 0. So that means x would have to be negative 4. So there's your solution. So your answer, you would just say x equal 1/2, comma, x equal negative 4. Now on my math lab, don't put x equal. On my math lab, you're going to just write it as, and usually they'll have a set notation. So you just say 1/2, comma, negative 4. Okay. So if you put x in here, it's going to mark it wrong because it's not recognizing the solutions. All right. So that was number 3. Okay. Number 4, we have 6x squared plus 11x minus 10 equals 0. Okay, so now we're getting to a point where our original problem is not factored. Okay, so think of these steps we went through. So in all of these, we talked about the fact that this quadratic equation was already factored. Okay, once it's factored, you use the zero factor property. All right, so basically, if you want to think about these as steps, so our first step, step one would be to make sure that the quadratic equation is in standard form. So step 1, write the quadratic equation in standard form. Okay, write the quadratic equation in standard form. All right, so that means in standard form, remember in standard form, right here, in standard form, you have all the terms on one side, 0 on the other, and it's in descending order. Okay, so your x squared listed first, your x is listed second, and your constant is listed third. So this is in standard form. It's in standard form, and so now we're going to factor it. And you just remember all your factoring properties that you did in previous lessons before we got to this point. So the first thing you're going to do to factor this is look for a GCF. The GCF is 1. So then we're going to go directly to the 2 binomials. Okay. Now remember, in this lesson deals with the chapter dealing with factoring. So all of our examples will be factorable. Okay. So you'll be able to find something that works. If it's not factorable, that's a later lesson. That's later on in the course. But for us right now, these are going to be factorable. All right. So let's go ahead and factor this. So I'm going to try 3x and 2x. So 3x times 2x is 6x squared. The last sign is negative. Remember the last sign is negative? So I'm going to just go ahead and do that. I'm going to do the work here and put the actual, if whatever works, I'm going to put it here. So let me go ahead and do that here, because I'm doing this by trial and error. So 3x and 2x. The last sign's negative, so that means one's positive, one's negative, right? So let's say this is positive, this is negative. If it doesn't work, I'll switch them. And then 10, the possibilities of 10 are 10 and 1, 5 and 2. Now, you got to remember some things we talked about. Would you put, let's say, the 2 here? No, because remember we had the discussion a while back that if you put the 2 here, that means that I could factor out a 2 from here, which means then that all these terms are divisible by 2, and 11 is not divisible by 2. So let's not put the 2 here. Let's put the 2 here and the 5 here. Okay? All right, now let's check. We got to make sure. Remember when we factored, just because you fill something out doesn't mean it's correct. You got to make sure you get these 3 terms back when you FOIL. So if I FOIL this, 3x times 2x is 6x squared, so we're good. Positive 2 is negative 5 is a negative 10, we're good. Now all I got to do now is check the middle term, and that's where the out and the inner comes in. So the out is a negative 15x, the inner is 4x. When I add them up, I get negative 11x. But what I wanted was a positive 11x. So those are opposites. So all that tells me to do then is to change the signs. And so if I change the signs, so I got to change the signs, right? Change signs. So then I'm going to get 3x minus 2 times 2x plus 5. Okay? And so that should work now. All you got to do is check the outer and the inner. So the outer now is positive 15x. The inner is a negative 4x. And when I add them up, I get 11x. Okay? So the first thing you do is to write in quadratic form. Then step 2 is to factor. Okay? So you're going to factor. And then step 3 is to use the zero factor property. Use the zero factor property. All right, step 3. And so then that means I'm going to set each of those equal to 0. So I get 3x minus 2 equals 0, 2x plus 5 equals 0. All right, so I went from a quadratic equation in standard form. I factored, and then I set each one equal to 0 using the zero factor property. And so then I solve. So step 4, you solve the two equations, or you solve the equations, the resulting equations. Because remember, it didn't have to be 2. It could be 3 factors, 4 factors. So solve the resulting equations. All right. Okay. So notice though that this quadratic equation, I end up with solving 2 linear equations. So I get 3x equal 2. And so if I divide both sides by 3, one of my solutions is 2/3. The other solution, if 2x plus 5 equals 0, then remember what's happening is we're subtracting 5, right? So you get 2x equal negative 5. So divide both sides by 2. I get x to be negative 5 halves. So those are your 2 solutions. All right. So now we're getting to the point where it's not in factor form already. So first of all, you got to put it in standard form. Then you factor. Then you set each one equal to 0 by using the zero factor property. And then you solve your equation. You got your solutions. All right, number 5. So let's suppose in number 5, I had this in number 5. Okay, so number 5, we have x squared plus 12x plus 35 equals 0. So x squared plus 12x plus 35 equals 0. So notice it's already in standard form, right? So it's in standard form. So I'm going to go ahead and factor. Go ahead and factor. The GCF is 1, so I'm going to go directly to the 2 binomials. This one's an easy one because the coefficient here is 1. So x times x is x squared. For 35, there's 2 possibilities, 7 and 5 and 35 and 1. So obviously I think the 7 and 5 are going to work, right? And the last sign's positive, so both signs in here are the same, and it's the middle sign. So just remember all your different rules that you learned in previous lessons. And so again, I'm going to put 7 here, 5 here, and then if you FOIL it out, you do get this back. And so now the next step is to set each of those equal to 0. So that's a zero factor property. So in order for this product to be 0, then either x plus 7 has to equal 0 or x plus 5 has to equal 0. All right. And so then I'm going to solve each linear equation. So over here, my solution is going to be negative 7. Over here, my solution is negative 5. All right. And if you check, now let me remind you, so if you check, always go back to the original because I could have factored this incorrectly. So if you plug it back into here, if you factor this incorrectly, you go back into here, then obviously your solution is going to satisfy this, but if this is not coming from here, then it's not going to satisfy this one. So you must go back to the original. Now what I would do is just use your calculator. Use your calculator. So let's check. I'm just going to check negative 7. So let's just check one of them. So let me just show you how to check this. So negative 7. So you go back to the original. So notice, so it's negative. So since it's negative, I'm going to go ahead and put, when I substitute, I'm going to put that in parentheses. So I get negative 7 squared plus 12 times negative 7 plus 35. And I want to see if that's going to equal 0. All right. So negative 7 squared. Now be careful, that's in parentheses. You see, if you do this, I want to remind you what happens. So you got to remember some things you've learned in the past in terms of using your calculator. So if you put negative 7 and you square it, then you all know that that's going to be negative, right? You had negative 49. But But according to this, I'm squaring negative 7. Negative 7 times itself is supposed to be a positive 49. So you got to be careful. That's why I said since it's negative, go ahead and put that in parentheses. So this right here is not true. You got to put that negative 7 in parentheses in order to get that positive 49. So here we go. So negative 7, just like this, parentheses, square, and then plus 12, parentheses, negative 7, close the parentheses, okay? And then plus 35, and then press equal, you get 0, all right? So that does work. All right, so you can do the same thing with negative 5, and you'll see that it does work. Okay, so that was number 5. Number 6, so let's suppose we have x squared plus 2x equal 24. X squared plus 2x equal 24. First of all, is this in descending order? Is this in standard form? No, it's not in standard form. Because remember, in order to use a zero factor property, if you're going to use a zero factor property, then what should be on the other side? The other side should be 0. Okay? So you need 0 there. So you got to put this in standard form. All right, so if I put this in standard form, I'm going to have to subtract 24 from both sides. Y'all agree? So I get x squared plus 2x minus 24 equals 0. Now, since it's in standard form, I can factor next and then set each factor equal to 0. So let's go ahead and factor. The GCF is 1. So if I factor, I get x times x is x squared. For 24, knows that's negative, right? So that means one's positive, one's negative. And there are several possibilities for 24. Just keep in mind you want the middle term to be 2x. So the thing that would work there would be 6 and 4. So I'm going to go ahead and put 6 and 4. And 6 would have to be positive. Now again, just check, double check. X times x is x squared. 6 times negative 4 is a negative 24. And look at the outer. I'm going to go ahead and do that here so I can show you. So notice if I do the outer is negative 4x. The inner is a positive 6x. And when I add them up, I get 2x, which is what you wanted. Okay? So once you factor, then what's the next step? Well, the next step is to set each factor, and you see two factors here. So you set each factor equal to 0. So I get x plus 6 is equal to 0. X minus 4 is equal to 0. And then you went from a quadratic equation to two linear equations. And so you just solve each linear equation. So this one is easy because right away you know that x equals negative 6. And over here, x equals 4. So those are your two solutions, okay? All right, now let me just remind you what some students will do, and you're gonna mess up. So it's very important. If you want the two correct solutions, it's very important that you are applying the zero factor property correct, okay? So what happens is that some students kind of mess up and they overgeneralize this. So see this right here where we had that original problem? So this is mistakes students make. So let me just remind you about this. So if I have x squared plus 2x equal 24, there are some students that will say, well, I'm going to go ahead and factor the left side because I think I can pull out an x. Well, that's true. You can do that. You can pull out an x. You can factor out an x. But they overgeneralize here. So they say, well, I have these two factors whose products are 24. So they think, incorrectly, they think, well, one of those factors has to be 24. All right, so they'll say, well, x equals 24. Over here, x plus 2 equals 24. So and then you would solve for x. So you get x to be 24, and over here, if you subtract 2, you get x to be 22, right? But notice, those solutions are nothing like these. Those are different solutions. So this right here, these, you see that 4? Let's say 4. So if I check 4, let's check 4. All right, if I check 4, go back to the original. So I have 4 squared plus 2 times 4. I'm sorry, the original is here. Plus 2 times 4, and I want to see that's equal to 24. What's 4 squared? Well, that's 16. What's 2 times 4? Well, that's 8. And is 16 plus 8 equal to 24? Yeah. But if I do this one, I want you to notice something. 24. You'll see that? 24. If you use your calculator, 24 squared 24 squared, 24 squared, 24 squared plus 2 times 24 is not equal to 24. It's equal to 624. Okay? So this is not true. So if don't overgeneralize this, and you're gonna see that again later on. Don't overgeneralize. The only time you set factors equal to a number when you have an equation is if that is 0. Okay? So that is 0. So the thing is this, the zero factor property applies only if the product is 0. That's the only way you can guarantee that one of the factors is 0. All right. So it's important, it's very important that when you have a quadratic equation and it's not in standard form, you first of all write it in standard form, then you factor. So that's why these steps were important. So step one said to write in standard form first. Then step 2 was to factor. Okay? All right. Number 7. Number 7, let's suppose we had this for number 7. We had x squared plus 7x equals 0. So first of all, is this in standard form? Yep, it is in standard form. What's the first thing you're going to do? All right, well, good. Based on what you've learned in the past, based on your practice, you know the first thing you have to do is to factor. And so here, the GCF is x. I can factor out an x. So I get x times x plus 7 is equal to 0. And notice that these two factors, I have two factors here, x and x plus 7. So that product is 0, so that means one of those has to be 0. So either x is 0 or x plus 7 is 0. Now, x is already by itself here, so I already solved for x, so there's one of your solutions. So one of your solutions is 0. Over here, x would have to be negative 7. All right, so those are your two solutions. And you can check, if you have time on a test, then check it. So let's check x equals 0. So you go back to the original. Don't go here, because you could have messed this thing up right here. Always go back to the original. So I get 0 squared plus 7 times 0, and the question is that 0? Yeah, it is, because that's 0, right? Then let's check x equal negative 7. X equal negative 7. So now remember, it's negative, so put that in parentheses. Negative 7 squared plus 7 times negative 7, and you want to see if that's equal to 0. Well, negative 7 squared is 49. 7 times negative 7 is a negative 49, and notice that is equal to 0, because 49 minus 49 is 0. Okay, so that was number 7. So notice that the procedure is the same. Standard form, factor, use the zero factor principle, and you got your solutions. And then if you have time, go ahead and check at the end. Okay, number 8. All right, number 8, we have 8x squared equals 7x. 8x squared equals 7x. Okay, so if you follow our steps, the first step is to put it in standard form. That is your first step. So I got to bring all these terms to one side. So let's go ahead and bring everything to the left side, since 8x squared, the leading term is on the left side. So I get 8x squared minus 7x equals 0. And now that looks like number 7. So I'm going to go ahead and factor this by factoring out the GCF. So the GCF is x. So I get x times 8x minus 7 is equal to 0. And so notice that I went from a quadratic equation. It's in factored form. So now I'm going to underline the factors. So here's my first factor. Here's the second factor. So if that product is 0, then that means, according to the zero factor principle, that one of these has to be 0. So you set each one equal to 0. So x equals 0. You already have x by itself, so that's your solution. Over here, 8x minus 7 equals 0. So you're going to solve this linear equation. So 8x equals 7. So therefore, if I divide both sides by 8, I get x to be 7/8. So these are your two solutions. So your answer, you're going to say x equals 0, comma, x equals 7/8. Now remember, on my math lab, they're going to have they're going to say so on my math lab they're going to have braces like this, and they're going to say inside those braces indicate the solutions. So all you do is say 0, 7/8. Don't say x equals 0 or x equals 7/8. In that case, is going to mark it wrong because they just want the numerical answer. All right, so that was number 8. Number 9. Let's suppose we had this in number 9. We have 25x squared equal 20x minus 4. So 25x squared equal 20x minus 4. Okay, so first of all, we got to put this in standard form. It's not in standard form, so I'm going to subtract 20x from both sides, and I'm going to add 4x to both sides. So basically, when I do that, I'll go from here to this. So I get 25x squared. So when I transpose 20x to the other side, I'm going to get minus 20x, and the negative 4, when I bring to the other side, I'm going to have to add 4 to both sides. I get plus 4 equals 0. All right. So now I'm going to factor this. And notice, I'm hoping you notice that this is a perfect square trinomial. So when I factor, that means that these two factors are be identical. 5x, 5x, 2, 2. Last sign's positive. That means these signs in here are the same, and they're both going to be this middle sign. And that's what you get. All right, and you can check it. 5x and 5x is 25x squared. A negative 2 times a negative 2 is a positive 4. And then the outer is negative 10x, the inner is negative 10x, and you get negative 20x. Now, here's what I want to remind you, or not remind you, but I want to tell you. So you see how those factors are identical, okay? So you just said one of them equal to 0. So we just do either one. So you're just finding a solution. So you're going to get 5x minus 2 equals 0. They're identical, so just do it once. And so you get 5x equal 2, divide both sides by 5, and you get x to be 2/5. So that's your solution. So you only have one distinct solution. So in every problem we've done so far, how many solutions were there? When we solved the quadratic equation, there were 2 solutions. Here you have one solution. And you have one solution because the factors were identical. That's why you had one solution. So you get one solution. So you answer. You're just going to say x equal 2/5. Okay? That's all you're going to say. Now, let me just say this because that's going to be important in college algebra. This right here is called a double root. Double root. You don't need to know that in here, but you do need to know that for a later course. So a double root, and that root means same thing as solution. So solution. So basically what that means is that 2/5 is a double root, a double solution, because it occurred twice. See, 2 times? So it occurred twice, but you only list it once. You only list it once. So don't say x equal 2/5, comma x equal 2/5. It's just 2/5. That's all you do. All right, number 9. So let's look at number 10. So let's suppose that number 10, I had this in number 10. Okay, so number 10, we have 4x squared minus 49 equals 0. So at this point, you notice it is in standard form, but I want you to notice that you have 2 terms, correct? So think about what this is. What does that look like? That looks like the difference of 2 squares. And so I can factor this as, and the GCF is 1, by the way. So I'm going to go ahead and factor this 2 binomial. So I can factor this as 2x minus 7 times 2x plus 7, right? And so you have two different factors whose product is 0, so you can get 2 solutions. So now I'm going to use a 0 factor property. So I said each one equal to 0. So 2x minus 7 equals 0. 2x plus 7 equals 0. And so notice that I went from a quadratic equation to 2 linear equations. So I get 2x equals 7. So if I divide both sides by 2, I get x to be 7/2. That's your first one. Your other one, if I subtract 7 from both sides, I get 2x to be negative 7, which means now if I divide both sides by 2, I get x to be negative 7/2. So those are your 2 solutions. So 7/2, comma, negative 7/2. All right? And you can check, and now here's how it checked it. You have access to a calculator, so let's just check one of them. Let's check negative 7/2. So again, you go back to the original. So I have 4 times negative 7 halves squared minus 49, and I want to see if that's equal to 0. Use your calculator. Notice, though, I put that in parentheses, so that parentheses is important. You must use parentheses. So you're going to say 4 times parentheses negative. Make sure you press the negative button, not the subtraction. Negative button. Negative 7 divided by 2. Close the parentheses. Close the parentheses, and then I square it. Then we subtract. You use your subtraction symbol. So I'm going to subtract 49, and then press equal, and you get 0. All right. And then you do the same thing with 7 halves. You get 0 again. Okay, that was number 10. Number 11, we have this. Number 11, we have 4x squared minus 28x plus 48 equals 0. All right, so 4x squared minus 28x plus 48 equals 0. Okay, so there are a couple of things I just want to say about this one. So the first thing you should do is when, well, first of all, notice it is in standard form. Then you're going to factor. When factoring, though, remember the first thing you need to do when factoring is to factor out the GCF. And so there's a GCF of 4 here, right? So if I do that, if I factor out the 4, I get 4 times x squared minus 7x plus 12 equal 0. And now that makes this right here a lot easier to deal with. Because now I get 4 times, and then I factor this as 2 binomials. I get x times x is x squared. This is a positive. The last sign is positive, which means these signs in here are the same, so they're both negative. And then you want a 7x, right? So the only thing you notice that's going to work will be a 4 and a 3. So 4, 3. And then you factor, and then you set each one equal to 0. Okay, now, if I set each one equal to 0, notice that this factor here is always going to be a 4. There's no variable expression here. That's a constant 4. That's a real number. So that's not going to give me anything. So these are the only two factors that have variables in it. So those are the only two I set equal to 0. So I get x minus 4 equals 0. X minus 3 equals 0. Okay, and then I set I solve each linear equation. So I get x to be 4 and x to be 3. So those are your two solutions. Now I do want to say this. Okay. If this was just a factoring problem, so that equal sign wasn't there, then you have to factor out the 4. All right? Now, remember, the problem here, though, is to solve the equation. So let me go back and just show you this. So the problem is to solve the equation. So if you forget to factor out the GCF and you just went directly to the 2 binomials, that's fine, because you're at the end solving for the variable, and you'll get the same answer as these. Okay, so there's two things I want to say now. Okay, listen carefully. Say it again. If the problem only said factor, which is what you did for the last however many lessons, then you have to factor out the 4. Okay, because you got to factor completely. Okay, even though the problem here is an equation, a quadratic equation, and you're going to solve this quadratic equation by factoring, you did not have to factor out the GCF here. You could have gone directly and said this. So listen to what I'm about to do. So let's see, 4x and x I think are going to work. So let's see, 4x and x. Then for 48, there are several possibilities. Let's try 12 and 4. No, that's not going to, yeah, let's try 12 and 4. So let's put the 12 here and the 4 here, okay? The last sign's positive, so that means both of those signs are the same, they're both negative. Now let's double check. 4x times x is 4x squared. Negative 12 times a negative 4 is a positive 48. The outer is a negative 16, right? The inner is a negative 12. A negative 16 and a negative 12 is a negative 28. All right, so I factored this. It's not. Now, I didn't factor it properly because I should have factored out the 4 to begin with, but I did factor it. It's just not complete yet. And I'm not going to worry about that. So now I'm going to set each one equal to 0. So I get 4x minus 12 equals 0, x minus 4 equals 0. And notice that if I solve this one, I get x to be 4, which is what this is right here. If I solve this one, I get 4x equal 12. Divide by 4, I get x to be 3, which is this one. Okay? So notice though, see right here, I did not factor out the 4, so it's a little bit more difficult to factor. See how much easier it was to factor this? Once I factor out the 4, here was a little bit more difficult. All right, so always when solving an equation by factoring, it is always easier to factor out the GCF first. All right, but just distinguish between problems that says factor versus problem that says solve a quadratic equation by factoring. Okay? All right, and then let's do one more. So this is going to be number 12. So it is possible that you could see something like this. So we have 2/3 plus 5y. And I just did a different variable here because I just realized that all the other problems I had variable x's, but it doesn't always have to be x, right? You saw that before. 1/5 minus 3y equals 0. Okay, so notice that this is already factored for you. And it is quadratic because look, if I FOIL it, 5y times a negative 3y is a negative 15y squared. So if you were to FOIL this out, you would get a quadratic equation. But it's already factored for you. So all you have to do is set each factor equal to 0, the zero factor property. So I get 2/3 plus 5y equals 0, and then 1/5 minus 3y equals 0. Okay? And so now we just solve, this is still a linear equation, so these are linear. So to get y by itself, I'm going to subtract 2/3 from both sides. So do y'all agree that if 2/3 plus 5y equals 0, then that's the same thing as saying 5y equal negative 2/3? Okay. Now, you got to remember some things that you've learned in previous courses. To get y by itself, I'm going to have to divide both sides by 5. Okay. And so I get y equal, now remember when you have a fraction divided by a fraction, negative 2/3 divided by 5, you're going to change this division to multiplication. So you're going to say just remember, to change division to multiplication, you got to remember the phrase multiply by the reciprocal. So you're going to say the numerator, which is negative 2/3, times the reciprocal of the denominator. The reciprocal of 5 is 1/5. So this division becomes this multiplication. So the numerator times the reciprocal of the denominator. See, the reciprocal of 5 is 1/5. And so now if I multiply this out, negative 2 times 1 is a negative 2, and 3 times 5 is 15. And so there's one of your solutions. Over here, I'm going to keep negative 3y on this side just to remind you about something. So if you subtract 1/5 from both sides, 1/5, I get, this is 0, I get negative 3y equals 0, and negative 1/5 is a negative 1/5, right? So to get y by itself, I have to divide both sides by negative 3. And so negative 3 divided by negative 3 is 1. 1 times y is y. Now I want to remind you about something. A negative divided by negative is a positive. So that's going to be a positive. So I'm just going to, since I know it's going to be a positive, I'm just going to say this. So y'all agree this right here is going to be the same thing as saying a positive 1/5 times the reciprocal of a positive 3, so 1/3. Now if you wanted to keep the negative, you could. So it would be a negative 1/5. The reciprocal of a negative 3 is a negative 1/3. And then you just remember that a negative times a negative is a positive. So a negative 1 times a negative 1 is a positive 1. 5 times 3 is 15. Okay? So your two solutions, your solutions are x equal negative 2/15, comma, x equal 1/15. Okay? All right, so that was part 1 of solving quadratic equations using the zero factor property. Now the focus here, let me just remind you of the focus. The focus here was strictly on quadratic equations. So they're strictly notice that every of our problems involved a quadratic equation. So in another lesson coming up, you're going to see a polynomial that's not quadratic, but you're still going to use the zero factor property. You're still going to use the step about factoring, then set each one equal to 0. Okay? All right, so that's going to be the end of this lesson that deals with solving quadratic equations using the zero factor property.